In this lecture, we're going to see how we can overload the plus operator for our own types. And what we want is to be able to do something like this with our own custom type, which is the point class here. We have two objects for the point class. We have P1 and P2. The values are 10, 10, and 20, 20. And we want to add them up. We want the syntax like this to work. We want to take P1 and add P2. And what we get is going to be used to initialize another point, which is P3 here. And we want to take P2 and add another point that we built on the spot here. And the result of that is going to be used to initialize P4 here. And down here, we are adding 2 points that we create on the spot. One has the value 2020 and the other has the value 1010. And we're going to print information on the result of adding up these 2 points here. Okay, so what we want is for this syntaxes here to work. And if we try and use these syntaxes on the class as we have it right here, this is not going to work because the compiler has no knowledge of how to add 2 points. And the biggest problem is, what does it even mean to add 2 points in our C++ program? Does it mean to add up the X member variables? Does it mean to add up the Y member variables? As we have here, we have really to define this. And we are going to define this using a plus operator that we overload for the point class here. The syntax to overload operators is going to follow the rule we have here. You are going to specify the return type. After that, you're going to say operator, and then you're going to say the operator that you want to overload. In this case, we want to overload the plus operator. So our operator is going to be called operator plus. After this, we're going to have a pair of parameters, and we can really specify any number of parameters we need for our operator. In this case, we're going to be adding up 2 things. So we're going to specify one parameter because the other parameter is going to be the current object for which we are overloading this operator here. So this is the rule we're going to follow. If we try and apply this rule on our point class, we're going to get something like this. And this is going to be our plus operator. The return type is going to be point because by adding up 2 points, the result of that is going to be a point. The name for the function is going to be operator plus. We have to specify the operator keyword, and after that, we're going to add the name of the operator that we want to overload. After that, we're going to specify the other parameter because the first left operand is going to be the current object for which we are overloading this operator here. And the second operand is going to be the point that we want to add to the current point. Once we have this set up, we may specify that our member function here is const. This is something you may do if you don't expect your function to modify anything on your object. And that's the case here, so we mark this as const. And in the body of the function, we're going to do whatever we need to do to carry out the operation. Because we want to add up 2 points, we're going to take the X member variables, we're going to add them up. We are going to take the Y member variables, we're going to add them up. And the result of these additions are going to be used to set up the X and Y member variables of the point object that we're going to return from this member variable here. Once we have this operator in place, now our point class is going to support the operation to add up 2 points. And if we add up 2 points, we're going to take the X member variables, we're going to add them up. We're going to take the Y member variables, we're going to add them up. And the result of those are going to initialize the result point that we're going to return from this operator here. Okay, with our operator in place, the syntax here is going to work now. Now the compiler knows how to add up 2 points objects. So it is going to take the X member variables 10 and 20. It's going to add them up. It's going to use that to initialize the X member variable of P3. It's going to do the same for the Y member variable. It's going to take 10 and 20 here and add them up. And the result of that is going to be used to initialize the Y member variable of P3 here. And P30 is going to become a point with the X member variable 30. And the Y member variable is also going to be 30. This is what we're going to have if we run this program. By following the same logic, P4 is going to become 25 and 25. because for each member variable, we're going to take 20 and add a 5, and we're going to get a 25. And our point here is going to have an X member variable of 25, as we see here. And the Y member variable is also going to be 25. This is what we're going to see. If we print the information here, we're going to get 30 because we're going to add up X and Y to get a member variable of 30. And we're going to add up 20 and 10 and get a Y member variable of 30. And if we print the information here, we're going to get a point with X of 30 and a Y of 30. One thing you should know is that if you carry out an operation like this, the compiler is going to do an operation like this behind the scenes. So if you do P1 plus P2, the compiler is going to transform this into what we have to the right here. And it is going to take P1 and call the operator plus on that. And it's going to use P2 as the second operand to this operator here. This is what we're going to have if we try to use this operator for our point class. I realize some of these things might be confusing, so we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is addition operator as a member. We're going to do this as a member function. We're going to grab our template files down here. Let's do this. And we're going to put them in place. And we are going to open this little guy in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file that we can clean up a little bit. Let's do this. And we're going to create a class which is called point to play with us. So let's do this. We're going to put in place its header file. That's going to be point.h. We're going to put in place a CPP file, which is going to be called point.cpp. We are going to head over to the header file and put in the code that we're going to be using as a starting point. It is nothing special. We have a class called point. We have two member variables, mx and my, and we have a bunch of constructors we can use to build point objects. We have a default constructor. We have a constructor taking two parameters. We have a destructor down below here, and we have a function we can use to print information about our point objects. Nothing special here. We're just going to be printing the mx and my member variables. And we have a length function or a member function, which is going to be used to compute the distance from the point 0. I think we have used this class a lot in previous chapters, so we don't need to do too much explaining here. Okay, so next we're going to head over to the CPP file and we're going to put in our simple implementation. Again, nothing special here. We are just putting in the implementation or the body for the length function. It's going to use the statement we have on line 5 here to compute the distance between the current point and the origin point. And we're going to be using this formula here. We have used it before, so we're not going to explain this too much here. What we want to do is to be able to go in the main CPP file and include our point class. Let's do this. And we want to be able to create point objects and add them up as we see here. For example, we want to be able to say P1 and P2, put in the values 10 and 10 and 20 and 20. And we want to be able to do what we see on line 9 here. We want to take 2 points P1 and P2 and add them up and get a point P3 that we can do things with. So for example, we want to be able to say P3 and print information, and we want to get 30 and 30 because that's what we want for this setup here. But if we try to do this by default, we're going to get a compiler error. We have a hint here. We see a squiggly line. So Visual Studio Code is not even happy about this. And if we look at the problems tab, we're going to see that no operator plus matches these operands, and operand types are point and point. So we have no member function or any function at all to help the point class support addition as we are doing on line 9 here. And if we try to build this program, you can expect to get a compiler error because the compiler doesn't know how to add up 2 point objects. And if we look at the compiler error we get, let's go up and see if we have something meaningful to look at. We're going to see an error saying no match for operator plus, and operand types are point and point. This is the problem we have. And we're going to have the same error repeated down here. And this is a problem. We need to help our point class support addition. And one way we have to do this is to define or declare an operator plus for our point class. In this lecture, we're going to see how we can do this as a member function, and we're going to see other ways we can do this in following lectures. But for now, we're going to do it as simply as we can, and we're going to declare our operator plus, and we're going to put that in the public scope of our point class. The way we define our operator, we want it to add up the x member variables of the operands, and it's going to add up the y member variables of the operands, and the result of the x member variables is going to be used to set up another point, and we're going to use that as the x member variable. And the result of adding up my is going to be used as the y member variable of the resulting point. So let's put this in code. Again, we're going to put this in the public scope of our class here. We can really put this anywhere. Let's put this in front of the printful function. Our operator plus is going to return a point object. The name is going to be operator plus. This is going to be the name. And then we need to specify our operands. When you set up an operator as a member variable like this, so the first operand is going to be the object we are calling this operator on. And what we need to specify in our operator here is really the second operand. Remember, in our main function, we are doing P1 plus P2. What the compiler is really going to do behind the scene is P1 operator plus, and it's going to specify P2 as the operand here. So we need to specify the parameter for P2 here. Let's do this. We're going to come back to our class, and the second operand is going to also be a point. So we're going to pass this by reference, and this is going to do it. If we want, we can put the body right here in the definition for the class. Let's do this here, and we're going to return a point object on the spot. And the member variables are going to be coming from the member variables of the operands. We're going to take the mx member variables and add them up. The first one is going to be from the current object, so we can directly say mx here. And then we're going to add the mx member variable of the right operand. Again, the first operand of this operator is going to be the current object. That's why we are taking the mx member variable directly. If we want, we can even use the this member variable because we have access to that. This is a member variable. We can do this. And after that, we're going to add the mx member variable of the right operand. So we can say right operand, and we can say mx. And this is going to give us the x member variable of our point here. We're going to set up the y member variable. We can do this on a separate line so that this is a little more clear. We can say this and say my, because that's what we want here. And then we're going to add up the right operand and say my. And this is going to give us the point that we want to return from our operator here. The moment we do this, you're going to see that the code we have in the main function is going to work. Let's try and build this now so that Visual Studio Code can pick up the new code that we have. You see that the error goes away. And now if we try and run this program, try to think about what we're going to get. We're going to bring up a new terminal we're going to be using to run this. And then we're going to run Rooster, our program. You're going to see that, by adding up 2 points, we're going to get a new point whose member variables are 30 and 30. And this is the design we did in our point class here. If you add up 2 points, you are really going to add up the member variables for the operands, and the result of those additions are going to be used to set up a new point that you're going to return from your operator here. And this is really cool. Again, the syntax is to say the return type, and the return type is going to depend on what your operator is really doing. If you want, you could even not return anything from your operator as long as the compiler is concerned. You're going to have to specify this depending on what you want your operator to do. So we have our return type. After that, we're going to specify the name for the operator, and then we're going to specify the second operand as a parameter, because the first operand is really going to be the current object we are calling the operator on. Again, in this case, if we do P1 plus P2, what we really are doing is taking the first point and call the operator on it. So we are basically saying P1 and saying dot, saying operator plus, and we are using P2 as a second operand here. So the first operand or the left operand is going to become the object on which we call our operator member function. You should really understand this. This is one way we have to set up operators for our own classes. Now that we have this, we can really play with this however we want. For example, we can go down and set up another point. We're going to call this P4. And then we're going to say P4 is going to be summing up the result from P2, for example, and another point that we build on the spot. We can do this. We can say point and put in a 5 and a 5 just to be able to follow this easily. So we're going to put a semicolon at the end because this is a statement. And then we can go down and say P4 print information. And we're going to print information about this. Let's build with GCC. The build is going to be good as you see down here. We're not using GCC. We are using the compiler from Microsoft. So let's wait for this to finish. But the build is good anyway. And if we go down and run this, we're going to see the output for our program. So P4 is going to be 25, 25. It is what we see here. And this makes sense because P2 has 2020N. And the second operand is a point whose x and y are 5, 5. So if we add them up, we're going to get 25, 25. And this is really cool. If we do ls, we're going to see that we have a lot of junk from the compiler from Microsoft in our folder that has our source code. I don't really like this, so I am going to remove all this clutter here. The way I'm going to do this, I'm going to reveal the location for our files here in Explorer. I am going to right click and choose Reveal in File Explorer. And I am going to remove everything I don't like here. I am going to remove this main file. Let's do this. Let's remove the point class. We're going to remove the rooster binary. And we're going to delete all these things and really leave in the main CPP file and the files for our point class. This is going to be better. And we're going to build with GCC. And it's going to do things in a much cleaner way. It's not going to put all this clutter in our folder here. And this is going to be much better. So let's do clear and run rooster. This is going to do what we expect here. Another thing we can do just to play with us is to set up 2 points on the spot, add them up, and then print information about the result of those guys here. So what we're going to get is 3030 printed out, and this is really cool. So let's do this. We're going to run the task to build with GCC. You're going to see that this is going to work. The build is going to be good. And if we run rooster, we should see 3030 printed out. And it is what we see here. And this is really cool. And this is really all I had to share in this lecture, showing you how you can set up an operator for your class as a member function. And one thing I should point out is that the addition operator or the plus operator that we just did is a binary operator because it is going to be working on 2 operands. Later in the chapter, we're going to see that we can also do unary operators, which are going to be working on a single operator. But for now, we're going to focus on binary operators that are going to be working on 2 operands. In this case, we saw how we could do our operator as a member function. Let's save this. This is a member function. And if you want, you can either put the implementation in the header file as we do right here, or you can even do it separately and put the implementation in the CPP file. You're going to do whatever helps you better. So for example, we can take this out. Let's comment this out. because I want you to see this as a reference later when you come back to this lecture here. And then we're going to grab the header for our member function here and just put in a header because we want the implementation to live in the CPP file. And we're going to grab whatever we have here and put this in the CPP file. We're going to go down and put in our implementation. We're going to move this a little bit to the left because that's going to be much better. And what we have to say here is that we want to return a point. And we're going to put in our scope resolution operator for the compiler to know that this function is coming from the point class. This is the syntax we have to use in our implementation file here. Just note that you can also do something like this and it is going to work. Once we have this in place, we can really build this as we did before. We're going to use the tags to build with GCC. This is going to build just fine, and it is going to give us what we expected. If we run this, we're going to get 30, 25, and 30 as our member variables here, and this is really cool. If you want, you can play with this, change the values in here, try to add up a few point objects, and you're going to see that this is going to work really well. This is really all I had to share in this lecture, showing you the syntax to set up your operator as a member function. We could either put the implementation in the header file as we do here. If we want, we can also put the implementation in the CPP file using the syntax here, and this is going to work just fine. We are going to stop here in this lecture. In the next one, we're going to see how we can implement our binary operator here as a non-member function, and that's going to come in handy on many occasions. So go ahead and finish up here and meet me there.